difference. Okay, so that property is nothing but linearity. We have learned the linearity, sensitivity, and the range. Now, the second B part of the question, the highest temperature that this thermometer can measure is 110 degrees Celsius. State the lowest temperature that can be measured. So, this thing you have to remember only. This kind of thermometer is called as a laboratory thermometer. The range is going from -10 degrees Celsius to 110 degrees Celsius. So, this is a particular thing you have to remember only. For laboratory temperature, the range is from -10 degrees Celsius to 110 degrees Celsius. So I will put over here -10 degrees Celsius. Now the third C part of the question, the liquid in glass thermometer has the same range but it has the greater sensitivity. So here it is the point of the sensitivity. Suggests two ways in which the second thermometer might differ from the first. So we had seen about the sensitivity before in one question. I told you when the sensitivity is higher, then we have the larger size of the pulp and the smaller size of the diameter of the pore or the capillary. So what two ways the second thermometer differs from the first is that it should have the bigger size of bulb. So you can write down the bigger bulb. We know that in the thermometer, the bottom we get the spherical region that is called as the bulb, and the capillary, which is also called as the bore. And we can have uh, bigger bulb and the I can write down here narrower bore, or you can also write down the smaller diameter of the capillary or the bore. So these two observations we can have for the greater sensitivity of the thermometer. Now we'll move to the next part of the question. Now the D part, thermometer has a bulb that is painted white and it's shiny. So this you can see it is painted white and it is shiny now. It is placed in a boiling water for several minutes. It is then removed from the water and is held in the air. So this figure shows the thermometer reading changes during the next 8 minutes. Okay, these are the thermometer readings. The bulb of this diameter is now repainted so that it has a matte black surface. Okay, now it is a matte black surface, and the procedure is repeated. And the question is that sketch the second line to suggest how the reading of the pre-painted thermometer changes during the 8 minutes. So what we have first of all the thermometer, which is painted here white and it's shiny, and the graph you can see it is put into the boiling water. So the temperature, initial temperature will be 100 degrees Celsius, and it will be decreasing as the temperature decreases. So the graph you can show we can see here it is decreasing graph as the time is increasing. It is going from 0 to 8 minutes, and the temperature is going from 100 to 0. So it takes 100 to 20. So it takes about 8 minutes to uh, go temperature to decrease the temperature from 100 to 20 degrees Celsius. So this is all when the bulb is white and shiny, and now it is painted with matte black surface. So what should happen to the graph? What is the difference between the matte black surface and the shiny, white shiny surface? We have learned in the chapter that the matte black is the color which absorbs more amount of heat, okay, and which also emits more amount of heat. So best absorber is the best emitter of the heat, and the white color is the one or shiny surface which absorbs less amount of heat, and also it emits less amount of heat. So it is a bad absorber, simultaneously bad emitter. So when it is a bad absorber and emitter, this is the scenario. If it is if the bulb is painted black, then of course the black color absorbs more amount of heat, and it also removes or emits more amount of heat. So what will happen? This bulb will emit more amount of heat, and then our graph will be different because the temperature would fall rapidly. In that case, temperature would fall rapidly because the black color is the one which will emit the heat rapidly, and that's why there is a fall of the temperature, rapid fall of the temperature. And that's why we can draw here the temperature graph. So the temperature graph will be like this. So there will be the rapid fall in the temperature. So we can write down, we can draw like this. It is going started from the 100 only, but it will reach 20 faster than the initial one. So this kind of graph we can plot for the matte black surface of the bulb, because it will absorb more amount of heat. So the water will lose more amount of heat, or rapidly it will lose the heat. So the fall in the temperature will be rapid. So that we can show in this temperature time graph. So I hope you understood why there is a rapid fall in the temperature, because matte black will absorb more amount of heat from that water, hot water, and that's why there will be rapid decrease in the temperature. Here it is to be drawn till 8 minutes, because in the question it is to be drawn during the all 8 minutes. Now we will see the second sub question in the problem. Now the second subpart in the part, you can see the tick one of the boxes to show how painting the bulb black affects the linearity of the scale, the range and the sensitivity of the thermometer. So once we painted it black, we painted the bulb black. What should happen to the linearity and the range and the sensitivity? We have learned this all properties linearity whenever there is a uniform change in the expansion of the liquid. The range is the one how much range of the temperature the thermometer can measure, and the sensitivity is all about how rapidly the or how small change in the thermometer temperature in the temperature that thermometer can read. So this all the properties are related to the bore, the size of the bore or the diameter of the bore, and the size of the bulb, okay, and the uniformity of the that diameter of the bore. So we can see here in option the linearity, range, sensitivity all change, all these things are given. But these all properties, as we know, are related to the diameter of the pore, the size of the bulb, and uniformity of the bore. So there won't be any effect in the range, sensitivity, and the linearity. So I would select here last box only, because all the boxes are telling us something about range and sensitivity and the linearity, which has nothing to do with the black color of that bulb. So I would select here last box. You can read in any box they have given something linearity, range, sensitivity all will change. Only linearity and range will change. Only linearity and sensitivity change. Only range and sensitivity change, like that. So that's why I've selected the last box. So here we are ending up with our structured problems.